Welcome to Calculus with Calculus. This is 8.1. So, L'Hopital's rule. The basic idea that you have to get from this chapter is that the limit as x approaches a of f of x over g of x equals f prime of a over g prime of a. So, start with an example. Example 1. So find the limit as x approaches 0 of the square root of 1 plus x minus 1 over x. So as we apply L'Hopital's rule, we're going to take the derivative of the top and the derivative of the bottom with respect to a, which in this case is 0. So d dx square root 1 plus x minus 1 over d over dx of x, where x equals 0, equals 1 over 2 square root 1 plus x over 1, where x equals 0, equals 1/2. So the limit as x approaches 0 of the square root of 1 plus x minus 1 over x equals 1/2. Show you another example. Alright, the limit as x approaches 0 of 1 minus cosine x over x plus x squared. So when you typically to find this, you would plug in 0 to x, but when you do that here, it ends up being 0 over 0. So you use L'Hopital's rule. You would set it equal to sine x over 1 plus 2x with x equaling 0, and that'll give you 0 over 1, which equals 0, and that's fine. So 0 is the answer to that. Show you another example. Example 3. These can all be found on your book on, I forget what page, but they can all be found in your book. Limit as x approaches 0 of square root 1 plus x minus 1 minus x over 2 all over x squared. And when you plug in 0, you'll end up with 0 over 0, which can't be a thing. Limit as x approaches 0. So we apply L'Hopital's rule here, and we're going to find the derivative of the top and the derivative of the bottom. I'm assuming you guys all know how to do that by now. So this is to the negative 1/2, and then 2x. And yet again, when you plug in 0 for x, you still get 0 over 0. So what we do is we take the derivative of the top and bottom once again, and we keep doing that until we get an actual value when we plug in 0. So this time it equals negative 1/4 1 plus x, so negative 3/2 over 2, which equals negative 1/8, which is not 0 over 0. So therefore, it is the right answer. So this is how you find L'Hopital's rule, or use L'Hopital's rule with the indeterminate form 0 over 0.